Greetings, my name is LAU SUE NEE and I'm the group leader of Group 13. Our project is titled Machine Learning Approach in Loan Approval Prediction. Our team collaborated effectively with each member contributing to research, data preparation, analysis, and project coordination.
Hi, I'm BONG and I'll be presenting our project background. Loan approval is the process of deciding whether to grant a loan based on the borrower's creditworthiness. Back then, manual approach is used but it's time-consuming, inconsistent and human bias, leading to inaccuracy and potential financial losses. To address this, machine learning is increasingly being used in loan approval systems. It improves accuracy by analyzing large data sets efficiently and detecting hidden patterns, resulting in faster and reliable decisions. However, challenges still exist, including evaluation limitations, interpretability, and data issues. The suggested model can be implemented in banks, credit unions, and fintech lenders that handle large volumes of data. The main users are loan officers, credit risk analysts, and bank management who use it to support data-driven lending decisions. Overall, this project benefits in improving processing speed, prediction accuracy, customer satisfaction, and also selection of optimal machine learning models.
So the problem is the bank receives many loan applications daily and rely on internal statistical model, and manual evaluation will be a problem. Moving on, many time will be spent to ensure the model is valid, especially do not know if your model is good or not since bank data are confidential. Last is that how the bank determines the criteria to approve the loan is not clear. So our objective is to identify the key factors to develop our models and choose the most accurate model based on performance metrics. This study uses a Kaggle dataset with 45,000 records and 14 variables to predict loan status. This scope is limited to classification-based models, and the final product is built using the models trained on this dataset.
Good day, my name is DAPHNE LING SUE EN. Let us continue with literature analysis. Earlier study using linear regression and random forest showed that machine learning can outperform traditional methods, but the results were models with limited comparison. Later study from 2024 onwards introduced advanced models like gradient boosting, support vector machines, achieving higher accuracy, and using richer dataset. Despite this advancement, several limitations remain. For example, small or specific dataset, no model comparison, no fairness evaluation, and missing performance metrics reporting, which reduce the reliability of the findings and limit how widely the findings can be applied. Although advanced algorithms improve accuracy, more consistent evaluation framework and broader benchmarking are still needed to identify the best performing approach.
Hi, my name is FOO JIA EN. I will begin with the data collection phase of our project. We are using a loan approval classification dataset obtained from Kaggle. It contains 45,000 loan application records with a total of 14 variables. And you can see in the pie chart, the dataset includes 8 numerical features such as income and credit score, and 5 categorical features such as education level. Besides, there is a binary target variable, loan status, where 1 indicates approval and 0 indicates rejection. At the beginning, the original dataset from Kaggle was already quite clean. To better reflect real-world scenario, we intentionally introduced some data issue using a Python script. We added missing values, inconsistent formatting, duplicate records, and extreme outliers. You may refer to the Python script and the result in the slides. After that, data cleaning technique will apply, including removing duplicates and standardizing the inconsistent values such as eliminating the percentage sign and dollar symbol. We also identify and treated the outlier using histogram and box plot, and handle missing value using mean and mode imputation. As a result, the final dataset consists of 44,978 records with no missing value or duplicate entries, and is now ready for EDA and modeling.
After data cleaning, the loan status distribution shows that only 22.2% of applications were approved, indicating a significant class imbalance. Correlation analysis identifies loan percent income as the strongest predictor, followed by interest rate. Higher income reduces rejection likelihood, indicating that financial burden is the most influential factor. For multivariate analysis, income shows a right skew distribution, while age and employment are moderately distributed. Gender and education show minimal impact. Overall, financial variables dominate prediction over demographic factors. This study emphasizes data privacy, fairness, and responsible model use. Sensitive financial data must be handled securely and used only for academic purposes. The model should support, not replace, human decision-making. As the dataset is synthetic, findings should be interpreted with caution. The next slides present our references. Thank you for your attention.